Welcome to Data Engineers Lunch number 109. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Our topic for today is Transcending Microservices Hell for Supergraph Nirvana, and it will be presented by Chris Toth. They will discuss insight into backends for databases and why many organizations are starting to create their own GraphQL-based data supergraph. The co-organizers for this event are Rahul and myself. If you are interested in being a co-organizer and want to help get speakers by reaching out to people in the data engineering community around the world, drop an email to me. You can email me at the email on the previous page or at marketing@anon.us. If you yourself are interested in giving a Data Engineers Lunch or our sister event, Cassandra Lunch, please feel free to reach out to either emails as well. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally centered around data, and you can find out more about all the various different groups and events at datacommunitydc.org. At Data Engineers Lunch, we cover everything from the ingress and egress of data and everything in between. We cover databases, ETL data wrangling, data engineering, and all of the tools and processes in the data engineering world. If there's anybody new that would like to say hi, what brought you here, or what you hope to get out of this, please drop something in the chat. And as always, don't forget to like and subscribe so you can get notified every time we post a video or go live. A few rules. If you have a question, please ask it. Chris indicated he wanted me to bring the questions from the chat to him at the time they're asked. So we'll get your questions answered quickly. Be polite and courteous to others. And this is a community. Please share what you know with us. Here at Anon, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. We also have a burgeoning generative AI practice, and we're here to help you with a wide variety of software automation and database needs. Thanks to all of our sponsors, including DataStax and George Washington University, and all of our institutional and organizational sponsors. If anybody has any job offers or you're looking for a job, please put links in the chat. If anybody has any meetups, hackathons, classes, or conferences that you would like to promote, please post those links as well. We host Data Engineers Lunch on Mondays and Cassandra Lunch on Thursdays. We have a lot of great chats in our YouTube history, and you can find out more about all of these events at anon.us/events. Finally, we've released a series of public runbooks on Cassandra. I worked on these and they're very interesting. Please feel free to go to the site, download the most recent one, and then you can access our history of runbooks as well. With that, I would like to thank Chris for being here, and I'm going to pass the baton to him. Thank you, Chris.
Thanks, Nick. Let me share my screen. Before I share my screen, just wanted to introduce myself. I'm Chris Toth. I lead pre-sales at Hasura. Been with Hasura for a couple of years, really focusing on unifying real-time data access for organizations and providing the best supergraph possible to be able to pull data together from all of your data silos across your organization. Prior to Hasura, I was at SAS and FICO for the better part of a couple decades and started in software up in Canada. So if you hear process, that's my Canadian coming out. And I was doing e-commerce and web development up there for some boutique shops. So very nice to meet everyone. Was just curious, who's heard of Hasura before?
I most certainly have.
Yeah, absolutely. Let's see if people on the YouTube chime in. But yeah, we've been evaluating the GraphQL landscape for a while, and because of our partnership with Yugabyte and just working with Postgres a lot, Hasura is definitely one of the ones we look at when it comes to GraphQL. So.
Excellent.
Now we're just seeing your VS Code.
All right. Give me a moment. There we go.
There we go.
Excellent. Everybody see title slide?
Yes, we are.
All right. Technology is wonderful when it works. Okay, so for those of you expecting angst-filled ballads from the 90s, no such luck on this particular talk, but would love to illuminate folks through a brief history of time with respect to app development, then really covering what is a supergraph and why do you need it, and why should you care about composability? What the heck is composability? Followed by a quick demo, and please feel free to ask questions throughout the session. Makes it a lot more interactive. All right, let's kick this off. So, through the history of time and software development, the right way to do things changes as we learn and evolve best practices. So, back when I started with the internet, way back when in the mid 90s, when I was 5, there was just static pages. So you had servers sending static pages to clients, and then every time there was navigation, it reloaded the pages. And well, it left a lot of room for improvement. Then we had edge side includes, where client would load a page and then send requests back to the server, which would then pass down dynamic content. Then you had the advent of single page applications, or SPAs. And there you had a lot more interactivity. There was a lot of back and forth between clients, between the client and the server, and it allowed a lot more dynamic and interactive experience. And then that evolved to more of a component-driven application using React. So everything evolves over time and gets better, gets more sophisticated, allows you to add more functionality and better user experience. And likewise, same with data and the way that we integrate applications. For a long time, we had the API charge and having everything be API led. Everything was needed to be able to talk to an API and pull from an API and push and have APIs exposed. Then with the advent of big data, you need to store all of this data. And that's where many of you folks come in, being data wranglers of, all right, well, we've got all this data lakes and lake houses and whatnot. And especially with the advent of event streaming, there's so much data out there. And, what do you do with it? How do you access it? And then, for real-time applications, you may be taking a slice of that and putting it in an operational data store and using the data lakes for more operational decisioning, but it all depends. And now what we're seeing is data products, the advent of data products, whereby you have these various organizations and various teams within organizations sharing their data, both internally and externally, and allowing folks to be able to leverage that data. And so that's really where we see ourselves, is being able to help folks share data across the organization with, of course, all of the benefits of high performance and robust security to be able to only let users see data that they have permission to see. So if we look at the right way to design architectures, well, that's evolved as well. Way back when, well before my time, we had mainframes, and we had monolith applications, whereby there was a single application and that then read from various data sources. Then you had the advent of microservices when monoliths became really difficult to grok, and updating them was really tough with multiple teams collaborating at the same time. So those teams were then split up into building, sets of microservices, and then layering those microservices over the data, and then having the applications, which themselves could be microservices, calling the data microservices. And as you can see, there's kind of some complexity there. So, and when you add streaming data that's now being streamed into the various underlying data sources, those microservices now have to update and really respond to changing data conditions, and being able to then pass those new events up to those applications as well. So there's a lot of interactivity, a lot of complexity. How do you wrap your head around, where, if I need a new piece of data, where do I go get it from? Who do I call? What if it's not in the shape that I need? Then what? Well, really what we're trying to do, and what we've seen, is that folks are decoupling their APIs from the data. You've got the product teams who need to move in a hyper-fast fashion, and they're really orchestrating data access based upon what data they need for their application and user experience right now. And it's optimized for each of their application and their apps, and the teams own their app and their application APIs. And so you have different architectures being used, backend for front end, as well as API access. Then you have the data teams on the bottom half building microservices to be able to support these application teams, these product teams. But then they have to, one, build these new APIs and microservices. They then have to make sure that the domain modeling is properly done. They're performant microservices, they're reliable, and there's proper security with authorization and authentication built in here. And typically, each of those domain teams own both the data and the microservices. The microservices may be built by separate folks than those who are managing the data itself, and sometimes not, depends on the organization. But as you can see, it's really, really complicated to be able to understand, well, where do I get the data that I need, especially for folks that are new to the organization, that just joined. How do I go get it? And then if I need new data, who do I ask? How do I pull it in? How do I get permission to view the data? How do I query that data in a performant fashion? And how is all of this process done quickly? So, when your boss asks, well, can you please show me a prototype of new website with loyalty points added to the customer portal when they look at their account information, for example. So now you have folks scurrying to go get the loyalty points from the marketing database, which is, of course, different from the source of truth where account information is brought in. So once again, there's a need to be able to collaborate in a very fast and efficient fashion. And that's where a supergraph comes in. You have a unified semantic graph that connects all your data domains. You're able to have a monolithic API. Yes, I said monolithic, but in this case, it's a good thing because it allows all of your data to be accessed from one API in a unified fashion. It allows all of the relationships to be automatically documented and visible via the graph. And if you see here, you have not only graphs within each data domain in the blue, black, and green colors, but you also have these orange relationships. Those are the fun ones. Those are the valuable ones because that's where you're linking data across systems and really gaining that extra level of insight and value for the customer. But those are the toughest ones because now you have to start making queries not only within your data source, but across data sources. And it could also be across domains and teams that are accessing. So there needs to be not only intra-team collaboration, but collaboration across multiple teams as well. You also need to have a really efficient and high performance query engine to be able to do efficient query planning and routing, both the query planning within each domain and data source, as well as being able to unify that across the data sources themselves. And then, of course, you need to have federated ownership of these subgraphs here. And what that means is really each team owns their own graph of data and is able to then control the speed and velocity at which they update their own graph. There's no dependency on other teams, but there's also safeguards in order to make sure that there's no conflicts within the supergraph. There's no breaking changes. That's highlighted and identified at build time, and actually even pre-build, there's pre-build validations for any new changes that are brought into the subgraph and then pushed to the supergraph.
So,
And
Chris, I've got a question that came up for me on this slide, if this is a good moment.
absolutely.
Sure. So I look at this, and the first thing that came up for me is zero trust, right? How is having a single monolithic endpoint that theoretically exposes all of your team's data, how does that like gel with a zero trust reality of law enforcement data or medical data or legal data?
That's an excellent question. So when I mentioned the federated ownership and each team owning their own data, they also own who gets to access that data and what access they get. What are they able to see and what are they able to modify? Typical CRUD operations. And with respect to that, what you're going to see initially in the demo is an admin view. So you see the entire supergraph. But realistically, what each application sees and potentially each group of user or each role within that application only gets to see a small fraction of the supergraph that they have access to. Now, that could be a small fraction, or they could see a wide span. But it's not just seeing what data is accessible, but also and what's accessible on the graph from a data type or data model perspective. But it's also a matter of, all right, when I make a query to a particular table, what rows can I access? And how can I lock this down in a standard fashion, not just specific to, let's say, Postgres or Snowflake or MongoDB, for example, but across a variety of different data sources and have that same consistency so that teams can pick this up really, really fast. Does that answer your question?
Yeah, thank you.
Cool. Any other questions at this point?
None from the chat yet.
Okay. Excellent. So if there's one thing you can take away from this talk is what's a supergraph? Supergraph is an architecture and operating model to build and scale multiple data domains as a single graph of composable entities and operations. So what does that mean? And where does that supergraph term come from? There's a few of us within the GraphQL community that, came up with supergraph, and that we're now throwing around the term quite a bit in the last couple of years. But technically, it's been a dozen years back in 2012 when Supergraph was architected and designed at Facebook. That started with the Supergraph vision that we still adhere to today, is really the unified semantic graph to be able to unify all of your data across the organization. That supergraph ended up being implemented under the covers with GraphQL, and that was also built, initially designed and built at Facebook, Meta. And out of this effort, GraphQL was shared with the open source community. But Supergraph was just there in concept and implemented behind the scenes at Meta. So what should a supergraph do? Well, as I've discussed a little earlier, it needs to be unified and semantic. So it's describing data both within your domain and relationships across each of those models within your domain, as well as across domains as well, as you saw in the earlier diagram. It needs to be composable. So you make one single API call and have the supergraph automatically figure out where it needs to get the data and be able to traverse that graph and efficiently pull data from all of your various data sources. There can be multiple data sources within a single domain and also across domains, and be able to pull those all in one shot, all in one query. Then you have SDLC and data governance. And that governance is delegated to each team because they know their data best. They know what data is PII or PHI, and who should have access to that data. Back to that zero trust question. And there's also no centralization, so there's no single point of failure. And then lastly, the supergraph has to be efficient because, well, if it's slow and hard to work with, then what's the point of having it? So it needs to be able to process API requests, create an optimized query, manage the execution both across domains and across regions, and have really high performance and low latency. All right. Well, if you join all your data together in a supergraph, but you don't have composability, hooray, you've built an API gateway, because you're essentially just surfacing the data, but not that much has changed. Okay, GraphQL is really, really cool. You can just query what you need, and you don't need to overfetch data. You can make multiple queries at one time. But if you're not leveraging the relationships, both within the domain and especially across your domains in a federated fashion, then you've only just seen the tip of the iceberg with respect to composability. So, from a supergraph perspective, SUR builds the best supergraph possible. That is our aim and our mission, to be able to build the best graph for you. So you have a single monolithic API with incredible speed, composability, be able to pull data from anywhere within the organization that's in the graph. You also have a really easy way to onboard new domains as subgraphs into your supergraph. And we tie into modern CI/CD workflows. And it's all declarative. So it's also really, really easy to audit. And lastly, from a platform perspective, you need to have an API that has guaranteed SLAs. It has a standardized way to create APIs very quickly so that organizations can share this knowledge and have a standard way to build APIs across the organization. So if folks move from one team to another, it's really easy to pick up where somebody left off because it's all declarative, it's all metadata. And of course, this is all built on an edge network, incorporates auto scaling, leveraging Kubernetes, and there's federated governance that, of course, is delegated to each of the teams, data teams.
Question
Pardon?
from the chat. So, in your data layer here, I'm seeing, database symbols. Does this supergraph architecture also work for object or file storage?
It can. We're actually looking for folks to create data connectors, let's say an S3 data connector, for example. We have a data connector architecture that is plug and play and allows both accelerated development velocity for us to be able to create connections or connectors to new data sources. And also, we've completely open sourced this, and we've open sourced all of the connectors that we've built as a template and set of examples for folks to build their own connectors and really expand the universe that can be brought in. Typically, we see databases, APIs, and bringing in other GraphQL schemas as subgraphs that may already pre-exist into our supergraph. But having file access is certainly an option.
Great, thank you.
Any other questions?
Let me double check here.
Yeah, actually, I have one. So I see, at the DDN edge, it reminds me of like CDN and SDN from Algolia, which is search delivery network, and there's all of these edge or widely distributed data delivery systems. How do you handle the invalidation of data if is it always getting it from the source, or are there ways to tune it a little bit? Or I'm just curious, how do you manage the lifetime of the data?
Of course. So first time you get data, it's always from the source. We are releasing caching shortly. We have on our V3 platform, our new DDN supergraph. Caching already exists within our version 2, but it'll be here shortly. And caching is what allows you to accelerate performance, but as you mentioned, the cache needs to be invalidated. Typically, we would suggest caching data that is regularly queried by a variety of users, as opposed to caching. It's response caching that we have at this point. And but we're looking to make our caching better and more robust. So there are ways to invalidate that cache as well. But the overhead for the Hasura supergraph versus native access is infinitesimal. Our whole purpose in life is to be able to federate data across the supergraph with minimal overhead, so we're an obvious choice, right? Does that answer your question?
Yep, thank you.
Cool.
One other question from the chat.
Yes.
What databases does this system currently support?
That's an excellent question. So we support, actually, I believe 100+ data sources with version 2. We're going to be, that's the version 2 support. We are going to have a rollout of a new set of connectors for version 3 to effectively support those same data sources very, very shortly. With our new version 3, the first database that's supported is Postgres, with a fast follow by Mongo, ClickHouse, and a variety of other data sources. I encourage folks to go to Hasura and check out our connector hub. Connector hub will be the place to see all of our latest connectors and all of the data sources that we support.
Great. I'll post a link for that in the chat. Thank you.
Cool. Thank you. All right. So, authorization. Hasura does it for free. And let me mention, not quite free like a puppy. So, so the idea is that it's all declarative, and Hasura is not only really, really good at generating APIs, but because it's declarative, it's also really good at maintenance and being able to leverage pre-existing authorization patterns within your organization that might be database, for example, and you might have a series of tables that model team and or asset-driven permissions, and we can really incorporate role-based authentication, role-based access control, context-based, and attribute-based, as you can see by the example. So you can get the customer role. Based on the customer role, they have access to certain models or certain tables, and then based upon the time of day and the location they might be accessing, that could then alter what data that they have access to. If they're accessing data from outside the organization versus inside physical building, that could also determine what access they have, what data they have access to. And then, of course, we can also do attribute-based access control, whereby you're only allowed to see the data that you've authored, for example, or that your department has created. So here's a sample GraphQL query, whereby we're going to get party. It incorporates the user model inside. You've got the tax number, the name. You've also got, from a KYC or know your customer perspective, their status, contact information, email address, and phone number. And then, in addition, you're also getting the points balance from a loyalty perspective. And each of these different colors represents different data sources that we'd be accessing with this query. So, because once again, everything is declarative, you can then see within a YAML document, all right, here's my model select permission for the users table. So here's users, that's the model here. This is the role customer. And then based on that, we've got a relationship, KYC, and then the comparison. So we're looking for where the PEP status is not equal to none. So it has to have a PEP status. And we're also making sure that the ID field of user is equal to the user ID or the Xasura user ID. These are session variables that start with Xasura, and those could be those could be defined either in a JOT or JWT or in headers. Typically, we find the most people use JWTs, and that we recommend that, and that's something that you integrate with your IDP, get a particular JOT back, and then within that token, you have claims that define what role you have, your user ID, and any other information you'd like to pass in from a permission perspective. So we're really, really flexible from that perspective. All right, so composability is included because, as you can see, when we make the query, the user model is queried from Postgres instance 1, and the representative query would be shown above, but we're also using push down predicates to pass in that authorization information. So when we're making that query, we're only getting the information that is accessible by that user ID. So by that nature, we're already more efficient because when we return that information to Hasura, to the Hasura layer, to that supergraph, we're already bringing back a subset. So it's going to be much, much faster from a data transfer perspective. We're not querying everything and then filtering it Hasura. We're just querying what is needed. Then we're now going to access second Postgres instance, points balance, right? And that's going to be leveraged, and we're going to use the user ID from the customer ID or user ID from the first query as an in clause in the second query. So we're making really efficient data access. And then lastly, we're getting the detailed KYC information from Mongo based upon the prior queries. Pause in case there's any questions.
Yeah, there is one in the chat, and this seems like the perfect slide for it. If somebody was trying to understand composability, how would you help them understand that?
One, it's by the nature of the graph, whereby all of your, think of it as a text-based visualization of all of the relationships within the supergraph. And I'll show this within the demo itself, but the idea is that we automatically pick up through introspection the models and relationships between models within a particular database using foreign key relationships, for example. So that's automatically brought in and created for you out of the box. Then, as you want to be able to create relationships across domains, it's really easy with the declarative format, and it all gets surfaced as part of the GraphQL types. And there is built-in tooling for GraphQL clients to be able to navigate this graph very, very easily. And I'll show you that within the demo. And this is available through pretty much all GraphQL clients through the use of an introspection query. That introspection query is a standard query within GraphQL that essentially says, all right, give me all the information about your graph. Give me all of the types, give me all of the relationships, and send this back to me in a standard format that all clients can understand. So that's typically how someone would understand the composability of the graph, or at least what's available. In addition, because of GraphQL's declarative nature, documentation is already available as well, because you can have comments within your schema to describe the various models and columns within those models, and that's then published within the automatic documentation of many clients. Does that answer your question?
I believe it does. Thank you.
Awesome. All right, without further ado, let's jump to the demo. All right. So what you see before you is a Hasura supergraph. You've got the core application. So in this case, we're modeling a e-commerce store. And so within the e-commerce store, we've got products, we've got carts, we've got items, cart items, categories for those products. And you can see that we've already picked up the relationships between these items, between these models, all automatically. And then you have a second graph where these are the communications. This is a communication domain whereby you have notifications, you have reviews, and manufacturers that may want to be able to look at the reviews of their products. And then you've got the sales application or the sales subgraph. And so this subgraph is now tying to a single data source as well. All of these are single data sources, but each subgraph could have multiple data sources within their domain. And for the sales domain, you've got orders, users, and coupons. So great. You've got these different graphs. We add more than just an API gateway because of these relationships intra-domain, right? Between cart and cart items, between product categories, this is automatically delivered to you. Great. But that's really just the tip of the iceberg, because while you still have no real way of being able to join this data together and compose this data in a nice, easy fashion across data. So if I come in as a user, can I see what orders I have? And based on those orders, get the product description that's in those orders. Well, right now I could, but that would mean two separate GraphQL calls because there's no relationship. Well, as I built out the supergraph, I then iterated and was able to create relationships across these, not only within each domain and within each subgraph, but also across all of them. So what does that look like? Well, here now you've got the power, the real power of a supergraph. So as I was mentioning, now we've got orders here. Orders is linked bidirectionally to users, to products. So you can see based on an order, what product, the product information. You could also query from product and see, all right, based on this product, what orders have been generated? And then you also have orders and carts, relationships between orders and carts. And you can see the whole interconnected graph. Well, great, this is a lovely visualization. How do I work with that? Well, let's go ahead and make a quick query. All right, so here is my supergraph. This is based on, we're actually embedding Graphql, which is an open source GraphQL client. I could also use Postman or Insomnia. Those are also great clients for GraphQL, not just for REST, which is what they're typically known for, but they also have GraphQL clients built in. And this view of all of the models and types is available. This Explorer view is available, and it provides IntelliSense for all of these clients based upon that introspection query that I mentioned earlier. All right, so let me go ahead and make a quick query. So we've got our sales orders, and I'd like to just review the ID, the order ID. Then we're going to go get the status and the created at and delivery date. Let's go ahead and query this. So I get a list of data. And so you can see right now we've spun this up and I'm able to get just the information I need. So I'm not pulling in the user ID or updated at, just get the information I need. So what does this look like? One thing I'll mention is right now, because we're a serverless platform, the first time you call it, it's going to be sluggish. And as you can see, we went from a little over 2 seconds to half a second, and now the performance is improving incrementally. For the second time is significantly better. So great, we've made a query. What does this look like? Well, what we're going to do is we can actually see the query details. We can look at the query planning. So we can see right now, we're just looking at sales orders and doing a model select. We can then see for that particular portion of the query plan. Right now, it's a simple query plan, so there's only one model that's being queried. And you can see the underlying SQL query that has been created. We're actually using some JSON functions under the covers within Postgres just to make it that much more efficient, so we can use the power of the database to create the JSON response, as opposed to having to do that at the Hasura layer, making the process that much faster. And you can also see the overall topology as well. So you can see the client makes the call to the Hasura runtime, and then well, actually, this is to the Hasura ingress or router. Then we pass it to the GraphQL engine, and then we're going to pass it to the underlying connector. So let's take a look at what this looks like from a span perspective. We've got the overall query. We have the fast authentication processing, and now we're going to handle the request. We handle the request. We then go in and execute the query, execute the request plan, and then finally we've got the database request as well. And all of this is collected in a standard OTel. So we have OTel metrics, logs, and tracing. All right. So now let's make things a little more interesting. Now, based on that, let me go ahead and get product information. So product information is now going to span to a different subgraph, to a different data source. All right, let's go ahead here and get the product name, the manufacturing ID, and the description. Actually, pick up the manufacturer. Let's just get the name and description. All right. As it's serverless, you can see performance improves in subsequent queries. Now we can see here's the GraphQL query details. We have a more sophisticated query plan. So we're now getting the data from sales orders, doing that query, which is the same as what we had before. And then we're also going into product based upon the results from the orders table. So you can see exactly what's being generated and how efficient the queries are. And then, of course, you can see the separate queries to each engine or to each data source. All right. So realize we're coming up on time. What I'd also like to do is show you very quickly, well, this is a great view that I have access to everything. You can see all of the various data that I've got access to within the graph. But what happens when a customer logs in? Well, let's actually I've already set up a customer role and the customer user ID. What you're going to see is now it's a significantly smaller view of the graph. So it could be a very large graph, but individual roles and users could have just slices of this graph or access to slices of this graph. And from a zero trust perspective, we don't show them what they have, what they don't have access to. So they only see what they can access. So let's go ahead and make this same query. So you can see we're going to go get sales orders, and now we're going to do it by a user ID. Let's go execute this query. And you can see that I only have a single order instead of that long list of orders that I brought back before. And so there's our built-in authorization, declarative authorization working for it. And what does this look like? Just like you saw in the slides, if I look to orders, I can see that I have type permissions. So this is telling me that based upon the role customer, these are the fields that I'm allowed to see. And if I scroll down, take a look at model permissions. So model permissions show me what rows I can access. So type permissions show me what columns I can see. And then here I'm saying based upon a select operation, here's my filter, and I'm going to be looking at the user ID and comparing it to the accessory user ID. And it's as simple as that. Any questions?
Not specifically about what you're doing here, but I'll maybe once you're done with the demonstration, I want to come back to some of like the strategic questions. I told you that I would give you a hard time about.
Of course. That's why I only left 5 minutes.
Yeah.
Veteran move, veteran move.
So, I think I've drank the GraphQL Kool-Aid, and I understand, I think what Hasura is bringing to the table. In the we work with distributed databases, so Cassandra, Scylla, Yugabyte, again in the open source world primarily, and then working with other we'll say variants, so key spaces or let's say Cosmos DB, or when you get into the distributed SQL world, you have Cockroach DB. So
Yes.
these type of solutions, GraphQL, is it's solving a problem that in distributed world we could say it's a client-side join, because we don't really have the means to do joins across NoSQL or non-relational databases. So it solves a massive problem when we start to do distributed databases, because technically everything is foundable or findable or queryable only because you have the particular key you're looking for, right? So That's cool that you guys are adding other databases like Mongo. So, question is, when are you going to add Cassandra? Because Cassandra also has a built-in JSON engine, which will give you the data back as JSON. Any thoughts on that?
Well, just to take one step back, we actually do have support for CockroachDB. I'm actually working on a Cassandra connector, a very, very simple one, just from a demo perspective that I've been working on for the last couple of days for Cassandra and leveraging key spaces. We're actually hosting the data on key spaces. So that's a very topical question. So
Awesome.
this, I'm not saying it's production ready, but I'm just saying that already have filtering queries available, just to be able to query on the partition key and the clustering ID, being able to, you can define the metadata to say, all right, these are additional fields that have indexes defined, and then be able to, query the primary key as well as add in an index. And then start validating some of the nuances where like, well, you can have an equality comparator operator for the primary key, or sorry, the partition key, but you don't want to use an in operator or comparison when using an index as well. So there's subtle validation that needs to be implemented within the connector, but it's really exciting of what you can whip up in a few days.
That's awesome.
Speaking from personal experience.
That's great. So, the use cases that it's well, I'm just telling you my narrative. You guys have a different narrative, right? GraphQL came out of Facebook because they didn't want to do 15, 20 REST calls to populate, the homepage that somebody was looking at. And what I've seen is that this type of one graph or super graph, for me, makes more sense in the enterprise world when you have a lot of different, data stores. And it just solves a lot of problems. Like for us, we call it the get your shit together problem, right? Get all your data together and put it in a bag, take it to the store and sell it, right? So get your stuff together, right? So when looking at GraphQL as a general technology now, and specifically Hasura empowering connectors and bringing it together, where would you say this is like the go-to tool for like a consumer application, millions of users or tens of thousands of users? Or do you feel like it's more in the enterprise world of, yeah, you can have a lot of people using it, but may not necessarily be for high transaction throughput? So I'm not giving you the answer either way. I'm looking for your opinion because I have my own opinion. I'm looking for yours.
So I used to say this with, in former lives, and I think it's applicable here. We provide a lot of flexibility, but with flexibility comes responsibility. Another way of putting it is we give you a lot of rope. You want to make a bow with it, right? So yes, we can support high volume customer facing applications. We can support B2B applications. Yes. Now, having said that, we offer you the flexibility to be able to do joins across multiple data sources, for example. But as soon as you make a hop from one data source to another, as much as we try, rewriting the laws of physics is coming in version 4. We're at version 3 right now. So there's still, we've optimized a lot of the cross data source complexity. There's still a little bit of latency that's added. But I think the value of having that composability and easily grabbing that data from multiple data sources is well worth it. Now,
Mhm.
when I mentioned you want to tie a bow as opposed to other things with the rope, you don't necessarily want to do a traversal of 10 different data sources. While you can, wouldn't recommend it. It's not necessarily going to give you
Mhm.
the results that you were hoping for. It is possible, so you can get that data. It's just going to take a little longer because we have to query 10 different data sources. But making a query across a couple data sources that may vary depending upon the data that you need, absolutely doable. And I think that's the power of GraphQL, and especially the power of a super graph. And our optimizations allow you to make really performant queries to each of these underlying data sources. With GraphQL, with DIY GraphQL, you can do the same thing, but as soon as you start pulling data from multiple data sources into a single query with relationships, you can make two parallel queries. We can do that too. And that's what most people do with GraphQL supergraphs. We allow you to really marry the different domains together.
Great. Yeah. And I'll just kind of, and, wrap this up with a comment that, we use GraphQL tremendously on the content side with Gatsby. And it's in one of those situations where we're materializing content, right? In those cases, you can have traversals that go 4 or 5 deep. It's okay because you're materializing the data.
Right.
I'm curious, and maybe this is something that your caching layer is basically doing, is that are there use cases where people materialize compositions for fast access through Hasura, or do they do it elsewhere and they just expose it as cache data?
That's a great question. Because we have response caching, we're able to do exactly what you said, is be able to cache the composition of data from multiple data sources, which makes it extremely performant.
Awesome. I think that's the big reason why we like Hasura, is this idea that once you bring it together, you don't have to bring it together again every single moment.
And I look
Right.
at this as this also can potentially alleviate a lot of ETL issues,
Yeah.
whereby folks are, creating ETL jobs to bring in data from their data lakes, as well as from multiple data sources. And there's actually a little blurb in one GraphQL article I wrote that, well, when you need to join data from multiple data sources, and you have to relate those data from data sources together, that's to just bring them into a single, that's time to create a single unified data source. We're trying to get rid of that. Why create more data duplication and more data sources when we can already access in place?
Awesome. Well, thank you so much for joining us, Chris, and thanks, Nick, for kicking us off. Whenever you get that Cassandra POC done, we have another sister lunch called Cassandra Lunch, so we'll have you back to showcase that.
Awesome.
Excellent.
Thanks, Nick.
Thanks so much, Chris. And thank you to all of our listeners. We'll see you next time.
Thanks, everybody.
Take care. Have a wonderful day.